Hi, and welcome back to the class, R for Journalists. In this section, we're going to make static maps. We're going to go over the basics of spatial data, shapefiles, and various ways to map census data. So, there are two underlying important pieces of information when it comes to spatial data. One is you start out with the coordinates of an object, and then you need to know how the coordinates relate to physical location on Earth. That's also known as the coordinate reference system. So there's two types of CRS. One is geographic, and that uses the three-dimensional model of the Earth to define specific locations on the surface of the grid. You'll know this as longitude and latitude. The other type of CRS is known as projected, and that's a translation of the three-dimensional grid onto a two-dimensional plane. So there are so many map projections to choose from, like Mercator, Robinson, Howard-Dyer, Gale-Peters. The one you've probably been exposed to the most is Mercator, also known as WGS84. So I want to talk about raster versus vector data real quick. Spatial data with a defined CRS can either be vector or raster data. Vector data is based on points that can be connected to form lines. Okay. For example, a road map. A raster map are values within a grid system. So satellite imagery is an example of raster data. This class will focus on vector data only and the SF package. An older package, SP, lets a user handle both vector and raster data. It also takes much more effort to get your system ready to handle it. So the main differences between SP and SF packages are how they store CRS information. While SP uses spatial subclasses, SF stores data in data frames, allowing it to be interacted with dplyr methods that we've learned so far in class. So let's talk about shapefiles. R can handle importing different types of file formats for spatial data, including KML and GeoJSON. We'll focus on shapefiles, which was created by Esri in the 90s. That's the most common type. So though we refer to shapefiles in the singular, it's actually a collection of at least 3 basic files. For here, there's about 5 each. So there's an s.shp file, which lists shape and vertices. There's a .shx file, which is the index with offsets. And there's a .dbf file, which is a relationship file between geometry and attributes. So all files must be present in the same directory and named the same, except for the file extension, to import correctly. So in this section, we'll walk through several methods for dealing with spatial data, each time improving on the style a little bit and the method. So the first method will map blank shapefile data after downloading it. Next method will join census data to a blank shapefile and map that. Next method is we'll use the R package Tigris to download a shapefile instead of downloading it manually. Then after that, we'll use an R package Census API to download census data and join that to a shapefile to map. And finally, we'll use Tidy Census package to download census data and the shapefile all at once. So we're going to use an SF package in conjunction with ggplot2 to visualize data. There's a note if you are using a Mac for performance issues when you're dealing with global mapping. Only if you're using a map. There's some extra instructions. So let's go ahead and open up the file. Static maps. I'm going to open up my script and work from there. First, we need 2 packages, library ggplot2 and library SF. If you don't have them installed yet, do install.packages, parentheses and quotation marks, those names. So because I am using a Mac, I'm going to use these couple of options. It's just an R-related thing where it will make visualizing it, instead of popping up through RStudio visualizing here, it'll use a separate program to do that. But if you're on a PC, just ignore me. Or if you're on a really fast Mac, ignore me. So first, I want to bring in the location data. And we can get that data from the census. They have a bunch of different types of shapefiles. This is usually where we get them. So let's look for state, look for the resolution. This is the smallest resolution. And we've got that. So I've already placed that in for you in the data folder and under static maps. So let's see, 50 location is static. For me, it's static maps / data / CB 2017 US state 20M / once again CB 2017 US. I need to type it. CB _ 2017 US state 20M.shp. Load that. It is now in the global environment. And I'm going to create a new object called 50 states, assign that, and use the function stRead _read. And that's the SF function to read in that shapefile and as a data frame. And there it is. So you see it imported down here, and it knows that it's a multi-polygon shapefile. It says the projection is NAD83. The 50 states, let's take a look at the file. And you've got GeoID, state ID number, abbreviation, spelled out name, and you've got the geometry. That's how this will interpret it as a shapefile later on. So, how do we visualize this in R? We can use ggplot. So ggplot, and the data frame is 50 states. And what is geom function? It is geom _ SF. Fingers crossed. Gonna take a few moments because it's quite a large span. Great. And it looks like that. Just blank data. So that's interesting. We have the boundaries of each state, including Hawaii, and I guess parts of Alaska. So ggplot2 is doing its best to fit everything on one image here, which is taxing on the system. Also, there are no colors here because we didn't specify that we wanted a color, and we don't have any data to fill it in with. So let's pull in population data from censusreporter.org, which is here. I've linked to that, and we're going to pull in population. So Census Reporter is a nice little wrapper for the census. Usually, as a journalist, you're probably used to Fact Finder. That's usually where you get your census data from. The only problem is it's very difficult to navigate and to figure out what you want from it. Census Reporter makes it slightly easier. So let's say we wanted to find population. Say total population, then you pick a place, states. And then you can select the regions down to census tract, zip codes. I chose state. And so this link right here is population for every race. So I can download this as a table. All right, and it's already here in your folder if you've downloaded all the class files. It's also under data, and it's simply under ACS 2016 1 year B2001. Yeah, so let me just type that out. I'm going to use the library reader, readr, to bring in the data. call this a new object populations, read underscore CSV, data slash, and it's ACS 20161 YR B02001 underscore 04000 US 55.csv. It's pretty much this one. Actually, one of these. Take my word for it. Oh, I need to point it to the right directory, which is static underscore maps. And then data. Okay, so now it worked. Populations is a spreadsheet. So we have the shapefile here. We have the population data frame, and it's got every state, including, of course, the summary of the entire United States, and B020010001, and then the error. These stand for these right here. So the first column is total. Next column is wide alone after the margin of error. And you can kind of just tell after working with population data enough, but you can always just Google it, B020010001 census, and then it should give you what that variable stands for, which is total population, right? Okay, so let's move on. Let's look for where we can join these two data sets at. Where's the key? And that is, let's see, we got the name for 50 states. That's one possibility. Another possibility is the GeoID 0100 US. Is there a match to that? Maybe. Let's see, I can always just copy and paste into this news one. Nope. Okay, so we need to match it on the state names. So under 50 states is name, under populations it's lowercase name. So we just use the dplyr function, library, dplyr. And that's loaded. And we'll start with 50 states that we're going to join to. We want to join to the map. 50 states is left join 50 states, comma populations, comma, that's the other data set. And now what do we want to join by? By equals C name, because 50 states, it's name all uppercase, and then name all lowercase. And let's see if that works. Populations name. That should have worked. Left joined by C. Oh, you know why? It's because it's got to be an equal sign. That's fine. Warning, it was a factor, but it converted it to a variable. I'm sorry, a character for us to join correctly. So now I've got 31 variables in 50 states. So this is the shapefile. And remember how it stopped at geography? Over here. Now we've also added all the population stuff. All these variables are now included. So let's take a look at the column names of 50 states. Pretty cool. So state FP is the state FIPS code. And that stands for the Federal Information Processing Standard. It's a standardized way to identify states, counties, census tracts. All these areas have a FIPS code. GeoID is part of that FIPS code. In this instance, it's only 2 digits wide. The more specific you get into the census boundaries, the longer the number goes. So a census tract might be like way more digits. But it always starts out with the state, and then the county, and then it gets more specific. So like I said, B002, etc. These are all stand for census variables. The error is margin of error because these are just estimates after all. And geometry is the CRS data I was talking about. So let's go back and map this. First of all, let's filter it a bit because we want to not slow down our computer too much. So I'm sorry, Hawaii and Alaska, you got to go for this example. So let's start with 50 states and filter and get rid of name doesn't equal Hawaii, and name doesn't equal Alaska. And also, I'm sorry about this, but gotta leave out Puerto Rico too. Okay, 48. So I went from 52 to 49 states. So I can do the ggplot on 48, and gonna use the geom sf. And what is the aesthetics? Is AES fill equals, and I'm going to choose the first one, which is total population. So that's B, that one, and I can copy it from up here. And then I'm going to add a little bit more style to it, and that's scale, fill, distiller, direction equals 1. And this is the way the direction of the scale, because if it didn't, it would reverse. So, and then I'm going to name the legend population plus, and then add a label. Labs title equals population of 48 states. Caption, going to source it to US Census. So let's run this. Ta-da! We just made a map with 1, 2, 3, maybe 4 lines of code. Not bad. Very basic. Notice that the X and the Y are latitude and longitude. So we've gone over how to bring in shapefiles and data locally, join them, and how to map it. There's a more efficient way of dealing with shapefiles if you know what you're looking for. So I will show you that real quick before we move on and end this video to move on to the next one. But first I want to show you how to download shapefiles directly into R instead of doing what I did here, which was downloading it from the census, unzipping it, moving it into here, and then reading the shapefile, stread, that takes a little bit of time. So let's use the Tigris package, which lets you download census shapefiles directly into R without having to unzip and pointed directories, etc. And file names and stuff. So this is Tigris. It's very cool, and you can see here you've got all the different types of boundaries that you can pull in: coastline, roads, places, blocks, and all these stand for actual functions. So Tigris, let's go. So first, let's make sure that the shapefiles download as SF files. Well, first, let's download and install library SF. I'm sorry, Tigris. Okay. You can enable caching if you want. So let's first set the options for all shapefiles that are downloaded to be SF files. Options, Tigris class equals SF. And now let's bring in Texas, the counties of Texas, and the function is counties. And you just pass the abbreviation of Texas, and you're going to give it the argument CB equals true, because that downloads a more generalized county shapefile. If you put in false, it'll download the most detailed version of it, which could take up a lot of space. And that's it. And we have Texas as an SP file. There's 254 counties. So let's plot that out really quickly. So ggplot tx plus geom sf plus, and I'm going to give it my mapping theme, which is theme void, and also get rid of some extra grid stuff that I know will show up. So theme panel.grid.major equals, and you know what, I'll give it make it transparent this time. Element line color equals transparent, and give it a label. Labs title equals Texas counties. Let's run that. Ta-da! Not bad, right? So notice how we used a couple of new lines to eliminate the axes and the grids and the background. So this is looking like a real map. We just need to add some data to it. And so we didn't even have to like download, install, unzip, point to the right the directory and all that. It's just, you just use this one line to bring in the shapefile. It was great. Okay, so that's enough for this video. We're going to move on. In the next video, we're going to talk about downloading census data via API, so you don't have to do the whole downloading and unzipping like we did. And then we're going to join it to this Texas counties data frame. So I'll see you in the next video.